So let's ask a hard question. What is the probability of an event? A much easier question is, given the probability of some events, find the probability of other events. So let's introduce some probability formulas. But first, the warning label. A formula is the automation of a mathematical process. It is a power tool of mathematics. And like all power tools, if you don't know how to use it, you're better off not using it. So it's important to understand, don't memorize formulas, understand concepts. So let's introduce some formulas. So suppose we know the probability of some event. Now definitions are the whole of mathematics, all else is commentary. So let's pull in our definition of probability. So let's start off with the probability of the union of some event A and its complement. Now, since A and A complement are complementary events, they're mutually exclusive. And since they're mutually exclusive, the probability of their union is the sum of the probabilities of the individual events. But since A and A complement are complementary events, their union is the entire sample space, so the probability of their union is the probability of their sample space, which by definition is 1. And consequently, we have a formula that tells us that 1 is the sum of the probability of an event and its complement. Now, earlier we gave this as a theorem, but it's also a formula we can use because if we have the probability of some event, then the probability of its complement will be 1 minus that probability. For example, suppose that 90% of the pies sold by a shop have gluten. If G is the event that a pie has gluten, then we have the probability of an event. So using the frequentist interpretation, this means the probability a pie has gluten is 90%. And while, strictly speaking, 90% is a number between 0 and 1, let's actually express it as a number between 0 and 1. So remember, a percentage is really a fraction with denominator 100, so 90% is really 90 100ths, or 0.9. Now, we know the probability of the complement is 1 minus the probability of the event, and so that gives us a relationship. We know the probability of G, and so that gives us the probability of G complement. Now, at this point, we'll invoke an important rule: respond in the same language. Note that the original statement is a natural language statement using percentages. So while we are technically correct in writing the probability of G complement equals 0.1, we should respond in a natural language statement also using percentages. And so we can interpret this: the probability a pie does not have gluten is 10%. Now, if I have two events, A and B, then A union B is the event that either A happens or B happens, and A intersect B is the event that both A and B happen. We'll see how to find these probabilities later, but for now, if we know one of these, we can find the probability of their complement. For example, suppose the probability that a zoo animal is neither fish nor fowl is 0.3. So if F is the event that a zoo animal is a fish and B the event that it's a fowl, then neither fish nor fowl means not a fish, F complement, and not a fowl, B complement. And so this event is F complement intersect B complement. And so we have that probability. But we also have De Morgan's laws that relate the complement of a union and the complement of an intersection. So here we have the intersection of complements, and De Morgan says that's the same as the complement of a union. And so we have really the same probability, just expressed in a different way. Now, our formula tells us the probability of a complement is 1 minus the probability of an event, and we could use it this way because we do have the probability of a complement. So if we take our formula, substitute in our values, and then solve, we find But again, a useful way to understand a problem is to solve it again. The formula relating the probability of an event and its complement came from this sum of the probabilities equal to 1. In fact, this is probably a better way to remember it, and we could have solved this for the probability of the event itself. And more directly, since we have the probability of the complement, we can then find the probability of the event. And finally, we should try to respond in the same language. We're given a statement in a natural language, and so the event F union B is that the animal is either fish or fowl, and so the probability a zoo animal is either fish or fowl is 0.7.